So we've got some further examples of integration by substitution. Just looking at that example, what do you think from your experience so far you are told in the question that u will be? It could either be e to the x, or as often, even the more complicated thing involving that. Yeah, it's actually here 1 minus 2 e to the x. Okay, it's given to you in the question. You haven't got to sort of guess it anyway. So it's been a while since I went through some of these examples with you. What's the first thing that we normally do? Find everything in the equation, yeah. So we know what the 1 minus e to the 2e to the x is. Rearrange it, see if we can get what e to the x is. So if everybody's happy about that rearranging. So I know what e to the x is. I know what the bottom bit there is. What else will I need to work out?
dx.
I will need to work out dx. Now what do I need in order to work out dx?
u dx. du dx.
And what else do I need? Even one stage before that. Over here I need to actually make x the subject of this. Okay, so I can get that next bit. So if I know what e to the x is, what do I need to do to go from e to the x to x? Log it, yeah. So over here this is log of 1 minus u over 2. And a calculator at the same time, please. So if we've got what that is now, at this stage we can work out dx du. We're logging something. You might find it easier to rewrite that as x is log of u over 2 minus a half. It's the same thing. It's often easier because you often see it like this, first of all, with the letter at the beginning of the sum in the bracket rather than at the end. So you could think of it like that. Is there anything you can do there, any way of rewriting that? Anything else you could do to help?
Take a half out.
Can't take it through the log. Can't take it through the log. Or is there any other way of rewriting that line over there which would be helpful? It's log of something divided by something. Do you have a rule anywhere for log of something divided by something from your other knowledge of logs?
Log A minus log B.
Yeah, that's the same as log A minus log B. If we use that law, that line there becomes x equals log of what's on the top minus log of what's on the bottom. So sometimes it's useful just to do it like the first way. Sometimes you can use this law of logs over here. And actually I think doing the last thing we've done here helps the most. Can we differentiate this line here? And I'm going to start with a bit on the back. Log of 2. What do you get if you differentiate log of 2? Log of 2 is just a number. So yeah, that's just a number, log of 2. So that will vanish when you differentiate it. So we're differentiating that bit there. And you might want to write it out as log of minus u plus 1 minus log of 2. To put the u bit at the beginning of the bracket. Sometimes it's easier to see it like that. So we've had integrals like this, differentiating stuff like this before. What do you get then if you differentiate log of minus u plus 1? If I write out again, it's log of minus 1u plus 1. Is that any help? We were trying to find a red box rule or some rule you know that tells you how to differentiate that. So if you differentiate that, what do you get? Sorry, I put that bracket in the wrong place. You're pretty much right. It's the derivative of the bracket. What's the derivative of the bracket?
Oh no, sorry.
Just the derivative of just the bracket. Yep. Over ax plus b. Okay. So that in there is what you get if you differentiate log of the bracket. So if I'm comparing that with this bit here, because I know the log of 2 is going to disappear when I differentiate it, what will I get when I differentiate that using this?
Minus 1 minus u plus 1.
Yes, that's correct. Okay. Now that doesn't look particularly nice the way it's written down. There are lots of minus signs there. Can we do something to that to make it look nicer? Cancel the minuses. Can you tell me what you think you're going to get if you do that? Because you might be right in what you're thinking.
Just minus 1, 1 minus u. Yeah, minus 1 over 1 minus u. Right?
Minus 1 over 1 minus u.
Yeah.
Okay, that's correct. You've just written the bottom in a different order.
Yeah.
That's fine. Is there a way of writing it down though using less minus signs? Again, if you're comparing it with something in a book or a model solution, model answer, what if you do this? If you times the top by minus 1 and times the bottom by minus 1, what will you end up with on the top?
1.
What will you end up with on the bottom?
U minus 1?
Yes, u minus 1. Okay? So that's just a tidier way of writing it. So again, if you're looking through things, if you've got lots of minuses on the top and the bottom, you can times the top and the bottom both by minus 1, because times it by minus 1 over minus 1 is just 1. So I've got my dx du bit. So from there, I want dx. So dx will be 1 over u minus 1 times by du. So, took a while to get there, but that's okay. We now need to go and stick things in the integration thing. So I'm running out a bit of space here. I'm going to write the original one down at the top of another bit of paper so we can see what's going on. Okay, so there we go. Right, e to the x. We decided e to the x earlier on was 1 minus u over 2. So the top of my fraction here, my e to the x is going to be that. My 1 minus 2e to the x, that is u, and that is being cubed. And I've just worked out that dx is 1 over u minus 1 du. So, if you do your substituting in, that's what you should get. You might not like this thing here, I call it a triple-decker fraction, a fractions of over a fraction. That 2 there, is that 2 like a dividing 2 or a timesing 2? It's a dividing 2. So that 2 there can just go down onto the bottom. And it then just does look more simple, more straightforward, if you put that 2 down on the bottom with that u cubed, which is also a dividing thing. Right, what do we always try to look for at this stage in the question? Things that will cancel. Can we cancel that with that? Are they the same? They're pretty similar though, aren't they? What could I do to this to make it into that? Times it by minus 1. Yeah. So if I now times that by minus 1 and that bit there by minus 1, and timesing both by minus 1 over minus 1, that doesn't affect it at all. On the top I get minus 1, and on the bottom I change the signs and I get 1 minus u. And at this point, what can you cancel?
The 1 minus u.
Yeah, the 1 minus u there and the 1 minus u there. Okay? So we are left with now a minus 1 on the top, a 2u cubed on the bottom, and a du. I would now take the numbers, which are just multiplying numbers, through the integral sign. I'll take that minus 1 through the integral sign, and that 2 through the integral sign, which leaves me with that. If you're going to integrate 1 over u cubed, what's the best way of rewriting that so you can integrate it?
U to the minus 3.
Yeah, that's right. Put a power on it. Then you can integrate it. Integrate u to the minus 3. Joe, what are we going to get?
Would be a half u to the minus 2.
Yeah, add 1 to the power, divide by the new power, and yeah, the minus you said, that's right, that's down there. That's exactly right. Okay. What can we do at this stage? Is there anything we can effectively cancel or get rid of? There's something on the top and something on the bottom somewhere. Yeah, a minus on the top and a minus on the bottom. Because they're being multiplied, we can get rid of those. The 2 times by 2, well, that's a quarter. So what I've got now is a quarter u to the minus 2 plus c. U to the minus 2, that's the same as putting a u squared on the bottom. That just makes it easier to look at, I think. Rather than have a minus power, stick that u squared down on the bottom. And if we go back to the very beginning of the question, we knew that u was 1 minus 2 e to the x squared. So we can actually come up with the final answer to that question. So that was a process of going through that question using integration by substitution. What I want to try and show you now is a much quicker way of doing the same thing. I think with the rule I think we saw before, but if not, you can be reminded of it. So let's just have a look again at that question. If you want to sort of put down their little heading there, we're going to have a look at just an alternative way of doing that same question. So this is like an alternative version. The question was e to the x over 1 minus 2 e to the x. That was cubed. If we don't think of integration by substitution at all, is there something I gave you in a previous lesson that might apply to this? Is there a red box rule I gave you? Yeah, that's true. So can you tell me? Yeah, I think everything you're saying, I think is correct. So can you tell me, how did I write that down?
F dash x on the top, and then it's fx on the bottom. Yeah.
And did we have it as well when? Well, we've had that one. Okay, let's write this one down first of all. What did we say we got from that one?
Log f of x.
Yeah. Okay. Now, here is the derivative of the bottom. What's on the top? Almost, yeah. We've got the power there as well. So it doesn't quite fit that one. Doesn't quite fit that one. I think we also saw this one. If you have a derivative of a function times a function to a power, I also told you what that was. What did that one become? If you look back in your notes, you should have it written down, I think. Pretty sure we did it. Have a quick check. It may have been from 3 lessons ago, something like that now. It's the function to the increased power divided by the increased power. Okay? Have you come across that one with me? Okay. So that one then may be new. But it'll save an awful lot of work if you can remember these and spot how they go. So, the question we started with, I'm going to rewrite that integral in a minute like this. E to the x, and then I'm going to write this thing here on the bottom, on the top, so I'm just going to introduce a minus power to it. So I've just rewritten the question like this. So comparing this with this red box rule here, what is my f of x going to be? If I match this up with this one here, what's f of x going to be?
1 minus 2.
Okay. What will f dashed of x be?
Yeah.
If it was just, if that minus 2 wasn't there, and there was a plus, it would be, but they've got this minus 2 there. What will it be if I differentiate that line there? No. It'll just be that e to the x being times by the minus 2. Now, no, that isn't quite what we've got over here, but we can sort that out. What would my n be over here? Minus 3. Right. So, does this work? Well, I've got my f of x to a power. Is this the derivative? Does that say that thing there? So, just make it right by doing that. But what else do I need to do? If I just times it by minus 2, what also do I need to do to keep it the same? Yeah. So if I put that at the front, do you agree that that black line there is the same as the question we had at the top? I describe this as putting in a sort of fiddle factor, making it fit the rule. Because now, that bit there is exactly that bit there. So you should now, just by using this red box rule here, be able to tell me what the answer to that question is. Just by matching it up and using the right hand side over here. What will the answer to that question be? Just remember, you have to write this minus a half that you introduced at the front down. And then what will this integration here be? It'll be my function f of x, which is this 1 minus 2e to the x, to the power of n plus 1, so that's to the power of minus 3 plus 1, to the power of minus 2, divided by the new power, which is minus 2. I'll put my plus c down. Now if we look at this, I've got a minus here and a minus there. What happens with those minuses? They cancel. Okay, I'm timesing here. I've got a 2 times a 2, that'll give me a 4, and that's on the bottom of the fraction. This bracket has a minus 2 power on it, so I could write it on the bottom without the minus, but put the 2 there. I've got nothing left on the top apart from a 1, put my plus c down, and I'm hoping that that is exactly the same as what we ended up with earlier from about 2 pages of work. And it is. Okay? So if you see things like these fractions, if you can rewrite them in this form, and you can spot that, it saves so much work. So, it's another question on the same topic over here. I'll write down the substitution that you would be given. Any comments?
Differentiate the bracket, you should get x to the 4 something.
That's right. If we look at this bracket here, if we call that for a minute our f of x, our function, and then if we're using that rule we had a minute ago, that's to the power of 2/3, what is the derivative of f of x? What's the derivative of this?
Minus 35x to the 4.
Yep, brilliant, thank you. Okay, now the rule we had a minute ago, I'm going to write it down so it's on this bit of paper, was if you have the derivative of a function times by the function to a power of n, and you're integrating it, you get your function to the increased power divided by the new power plus c. So that is the rule that we are using. So I'm just going to rewrite the question. I am integrating between 0 and 1, and I'm going to leave a little gap at the beginning. I have over here my function to a power. Now, I need written in front of it what Joe said, which is minus 35, just to emphasise that point, putting that in, minus 35 x to the power of 4. Now that minus 35 was not in the original question, so I've just times everything by minus 35. That's my fiddle factor, to make it fit. So what do I also need to do? Yeah, so put here minus 1 over 35 at the front. That line, my last line, is exactly the same as the top line of my question. So now, if you use this red box rule here, you should be able to write down the answer. Just remember to put that minus 1 over 35 down, and then you are timesing by. Okay, well, what am I going to write down after it? It's this bit over here. Do you want to tell me? What's it going to be?
8 minus 7x to the 5 to the power of 5 over 3.
Yep.
Over 5 over 3 plus c.
Yep, that's exactly right. That's what the red box rule tells you to do. Now it's just a case of making this tidy. So I've got at the front minus 1 over 35, and I'm dividing that effectively by 5/3. What do you do when you're dividing with fractions?
Flip it and
Change, flip, as some people say. Keep that one, change it to a times, and flip that one upside down. So if we're timesing these fractions together, minus 1 times by 3 is minus 3. 5/35s. 175. Yep. So that fraction there and that fraction there being divided together give you that fraction over there. So this answer here is minus 3 over 175 times by the bracket to the power of 5/3. Now, this integral was actually a definite integral. It had limits on it. And because I haven't gone into u's, I don't need to swap anything around. So I can now put my limits on here. But doing this little thing here has probably saved a page of work, if you can spot to do it. So the thing here, the key thing, just going back to spotting it, was look, power on here in the bracket is just 1 more than the power here. So that's suggesting if you differentiate this, you will get this x to the 4. Maybe a number's needed as well, but that will work. So here, substitute 1 into here, you will get, well, you can do this as well as I can, 8 minus 7 times by 1 to the power something. So that just becomes 1. Because when I substitute my 1 in there, I'm going to get 7 times by 1. So the whole bracket there is just going to become 1 to the power of 5/3, so that's just 1. And when you put 0 in there, you're going to get 8 minus 7 lots of 0, which is just 8 to the power of 5/3. And you're doing a taking away between the two of them. I haven't written that down possibly the best way. I hope you can follow that through. So over here, I've got minus 3 over 175 times by 1. Over here, I've got minus 3 over 175 times by... Well, what's 8 to the power of 1/3? 8 to the power of 1/3? 2. Then I need to do that to the power of 5. 2, 4, 8, 16,
16, 32.
32, yeah. So it's a 32 in there. Okay, that was a negative. There's a taking away sign between them. You could take the 3 over 175 out as a factor. If you bung that into a calculator, because your brains have probably gone to mush now, you should get an answer of 93 over 175. Okay? I just want to put on the screen and show you the other way of doing it using substitution, and then you can just make a judgment call yourself which way would you actually want to do, because you could do it either way. So that was the question we were given with the substitution. What process would we have gone through now up here? What would I have needed to do if I'm doing it the normal substitution way?
Find x.
Find x, yeah, okay. Rearrange that, find out what x is. Then what would I have done after that? Yeah, I could find out. Yes, I will need to find what x to the 4 is. So yeah, I can change that power there to be 4/5 to get that, which is nearly what I've done on the next line. I think I've done that a bit later on. What else do you need to do? Differentiate it. Yeah, that's the process I've gone through first here. I've decided to split it up into 2 bits. Might make it easier to differentiate. So what you've actually used here is, if you were differentiating this, a bracket to a power, what do you get if you differentiate that?
N bracket times the differential of the bracket.
Yes, which is just going to be the a.
Yeah.
Yeah.
A x plus b. So the n minus 1.
Yeah, okay. So that's what I've done here. Okay, my a is my minus 1/7. There's my b, there's my power. I've used that to differentiate it. Okay, as Jack said, I also need to work at x to the power 4 somewhere. It's a definite integral, so I need to swap my limits over. Okay, there's my power of 4 bit, putting that power of 4 in, substituting everything in. If you look at that line, what can you see on that line that's encouraging? What can you see on that line that's helpful?
Positive fourth of this bracket and like negative.
Identical bracket, you are timesing, you add the powers. When you add those 2 powers, you will get a power of, and the bracket will have a power of 0 and will therefore be 1. So that and that cancel out. Okay, you're left with this here. Integrate it, put your limits in, and you will get the same answer as we had a minute ago. So that's the alternative way of doing it, okay? If you want to stick with that way, absolutely fine. If you can spot the shortcut way, it's to your advantage. Okay. So this is the next example. It's a definite integral. We've got x squared here, x cubed plus 1 all square rooted there. The first thing that I would do is get rid of that square root sign and write that as a power of 1/2. Okay. So can we see any way of using any quick method? Joe, if we're going to do it, go on.
Do f(x) as x cubed plus 1.
Because that has got a power on it. What's the power then going to be?
1/2.
Okay, what is the derivative of the function you have given me?
3x squared.
Okay. Is that what we have got written here? No. So put a 3 in. And what do I have to do to effectively cancel that 3 out?
Put a minus. No, put a third.
Yeah, that's right. Put a third outside, because they cancel each other out. Okay, so we've got here our function to a power, derivative of the function. So this now does match up what we've got. We've got the integral of the derivative and the function to a power.
Is that a minus third you call out?
No, that's my equal sign there. Okay, so that's what we're using. The red box rule says on the right of that the answer is the function to the increased power over the increased power plus c. So that's the rule. That bit there is how we've applied it. So Joe, can you then tell me what the answer effectively, or what this will give me, what my next line will be?
X cubed plus 1 to the 3 over 2 over 3 over 2 plus
Adding 1 to the power, you're dividing by the new power. I'm not going to put the plus c, you would normally, but this is a definite integral, so we'll leave the plus c and I will put my limits on it, but there's something else important that hasn't been said yet. Look where I'm pointing. Yeah, the third, the fiddle factor you introduced outside has got to come down here as well.
If I put that inside the bracket.
No, it doesn't matter, you should put it inside the bracket. What I would be tempted to do now is to move that through the bracket, just like you did with an integral sign. So I've got here 1/3, that's on the bottom, so I'm dividing by 3 over 2. 1/3 dividing by 3 over 2 is the same sum as, anybody?
2 over 3.
1/3 timesing by 2 over 3. So that will give me what fraction?
1 over 3. Well, what do you want?
2 over 9.
2 over 9.
2 over 9, yeah. 1 times by 2, 2. 3 times by 3, 9. So I've effectively got 2 over 9 over here. I've got my x cubed plus 1. We can either leave it in the let's leave it at powers. I'm doing it between 1 and 0. When I substitute 1 in, what's the value of the bracket when I substitute 1 in there? So I'm going to get 2 to the power of 3 over 2. When I substitute 0 into the bracket, what's the value of the bracket? 1. So I'm going to get 1 to the 3 over 2, taking them away from each other, timesing by 2/9. This is a sort of question that may ask for an exact answer rather than a decimal. Even though your calculators these days give you exact answers, I think, anyway, don't they? 2. Well, you could just leave. You could, to be honest. Yeah, you're saying that's the same as root 8. Yeah. 2 to the power 3 is 8. Halving it, it's root 8. What is root 8 simplified as a third? Can you remember? Yeah, root 8 is 2 root 2. Okay, over here, 1 to the power of anything is 1. So there you go. There's your final answer in exact form. For the sake of completeness, I'll show you the process that's gone the other way, and again, if you can watch it on video, anybody else can later on. So that was the question we started with the substitution. What steps are we going to go through over here on the right?
What does x equal?
What does x equal? Okay, so rearrange it to get what x equals, then differentiate it, okay, to work out what I'm going to have for dx. It's a definite integral, so I do need to change the limits. My u numbers, I will cube my x1s and add 1 to them. That's where the u numbers come from. Substitute in, and I get that line. When you look at that line, what encouragement do you get?
The bracket thing again?
Yeah, the bracket thing in. Bracket to power, same bracket to same power, but a negative, so they cancel each other out. All you are left with is the u to the half and the third. I would probably have taken the third out through the integral sign, you know I like doing that. Do the integration, substitute in, and you will get the same answer. Okay? So that's the other way of doing that. So integral this time of cos x sine cubed x. You are told that u is, well, what do you think u will be from past experience? What's the nastiest bit here?
Sine cube x.
Yeah, so it will just be the sine x. Okay. So let's do this first of all, just the old-fashioned by substitution method, and then we'll try and see whether we could have done it a quick method. So here, okay, rearranging this, you're going to get sine to the -1. That's going to get messy. So this is one where the best way to go is actually work out du dx, because what will you get when you do du dx?
Cos x.
Which is already written in your question. Okay? So you now already know what that is and what that is. So you can just substitute them in straight away. Instead of writing cos x, you can write du dx. Instead of writing sine, you write u, but it's being cubed. Keep your dx there. But because you've got another dx down here on the bottom, they cancel out. So you're left with the integral of u cubed du. I'm going to go through this fairly fast because I know you can do this bit. U to the power of 4 over 4 plus c. Replace your u's with your x. And you get an answer. That one came to an answer very, very quickly. Not much manipulation there at all. Could we have done it using the other method? And if so, can we just tell me what would have been my function, my derivative, my fiddle factor, my power, all that sort of stuff? What would f of x have been if I was doing it the other way?
Sine cube.
Not sine cube, just sine, yeah. My power would be my 3. That's dealt with the sine cube bit. What would be my derivative? What would f dash of x have been? Cos. So here it meets the rule straight away. You actually have got f dashed x times by f of x to a power. So there's no fiddle factor. You'd have just written down your function, which is sine x, to the increased power, which is 4, divided by the new power plus c, and you got what we got up here. So that one, to be honest, it didn't save much time. But again, you could do it both ways.